Welcome viewers. In this video we will see the RL series circuit, that is resistor and capacitor is connected in series. Consider this diagram. Resistor and capacitor is connected in series and energized by the AC voltage. We will see what is the behavior of this circuit. What is the current, voltage, what is the impedance, power factor, power we are going to analyze. So here resistor or capacitor are connected in series, energized by the AC voltage. So the VR is the voltage across the resistor, VC is the voltage across the capacitor. So the description is given here. V equal to Vm sin omega t, that is the applied voltage. I is the current of circuit current at any instant. The capital I is the effective value of current. VR is the potential across resistor R. VC is the potential drop across capacitor. F is the frequency. Now in this series circuit, the same current I is flowing through the resistor as well as capacitor. So the current is taken as a reference vector. Now we are going to draw the vector diagram. In that we are taking current as a reference vector because the same current is flowing through capacitor as well as resistor. So based on that, this voltage across the resistor VR equal to IR in phase with the current. So the voltage across the resistor is I into R. So the resistor we know very well, it is always in phase with the current. The voltage across the capacitor VC equal to I into XC. This XC is nothing but capacitive reactance. So the capacitor always the current is leading, that is otherwise the voltage is lagging the current by 90 degree. Current is leading in capacitive circuit, and other words the voltage is lagging the current by 90 degree. So the voltage is now lagging the current. So based on that we have vector diagram is available, phasor diagram is available. So this is the voltage drop across the resistor, VR equal to IR. This is the voltage drop across the capacitor. So that is lagging the current. The capacitor across the voltage is lagging the current, so it is drawn downwards. So it is lagging the applied voltage, lagging the current. VC equal to I into XC. So sum of these two is the total potential. V is I into Z. The Z is nothing but impedance of the circuit. The vector sum of resistance and capacitive reactance is nothing but a impedance. So here voltage is lagging the current, so it is given in the downward direction. In case of RL circuit, the voltage is leading the current, that is current is lagging, voltage is leading. So in that case the inductive reactance will be drawn in upward direction. So leading, now it is lagging, voltage is lagging. So based on that we will go for the total voltage. V equal to VR plus VC, that is IR minus JIXC. So this minus sign indicates it is lagging the voltage. If it is plus J means leading the voltage, leading the current. So the minus J represents lagging the current, that's why it is given minus. So take I outside, so that R minus JXC. Bring the I in the denominator, so V divided by I equal to R minus JXC. So V divided by I is nothing but impedance, that is equal to R minus JXC. So in the magnitude we will taking modulus, it is nothing but square root of R square plus XC square. So this is nothing but a impedance. So impedance of this RC series circuit is square root of R square plus XC square. So this is a rectangular form. We can write in a polar form also, another form is available. So from this phasor diagram, we can find the value tan pi. Tan pi is nothing but adjacent side by hypotenuse. IXC divided by IR. IXC divided by IR. I get cancelled, so XC divided by R. So from that pi equal to tan inverse XC by R. So the angle, the phase angle pi is nothing but tan inverse XC by R. While writing polar form we can use this angle pi, right? Now this is the rectangular form, polar form we can use this angle. Now we'll go to the phase difference between current and voltage. So because of series circuit, the applied voltage can be written as voltage drop across resistor plus voltage drop across capacitor. This is one more analysis in order to get the angle between applied voltage and current. So VR is nothing but R into I of t. V equal to IR. So R into I of t. The voltage drop across the capacitor is 1 by C integral I dt. So formula is available. What is I of t? I of t is nothing but Im sin omega t. So R into Im sin omega t plus 1 by C integral I of t is Im sin omega t into dt. So that is R into Im sin omega t plus this Im is taken outside, Im by divided by C. The integral sin omega t is minus cos omega t divided by omega. So that what will happen here, R Im sin omega t plus Im by omega C. This omega is taken outside, so omega into C minus cos omega t. So this minus cos omega t can be written as sin omega t minus pi by 2. Right? Minus of cos omega t can be written as sin of omega t minus pi by 2. Now we have two terms available. Now we can analyze these two terms so that we are able to find the angle between current and voltage. So the first term R Im sin omega t is the voltage drop across the resistor. That is in phase with the current. There is no angle here. Only omega t is available. That means voltage drop across the resistor is in phase with the current. The second term refers the voltage drop across the capacitor. See here minus pi by 2 is available. That is current is leading or voltage is lagging the current by 90 degree. So this voltage is lagging the current by 90 degree. That's why we got the in the phasor diagram the voltage drop across the capacitor is drawn downwards. So from this two term we are easily identify that voltage drop across the resistor in phase with the current, voltage drop across the capacitor is leading 90 degree or voltage is lagging the current by 90 degree. There is a phase difference of 90 degree. The current is leading or voltage is lagging. So based on that we can draw the waveform. See the voltage is starts at 0 degree. We know that current is leading. So before starting voltage the current start here itself. The current starts earlier. In case of inductor the current start later. Here the current start earlier. So there is a phase difference of pi between current and voltage. That is current is leading or voltage is lagging. Here current is leading. So based on that we can write V equal to Vm sin omega t. It starts at 0 degree. But I equal to Im sin omega t plus pi because it starts earlier. So it is added. If it is later minus pi. If it is earlier means in case of capacitor the current starts earlier. So sin omega t plus pi. So from that we can easily add the current I leads the applied voltage V by an angle of pi. There is a phase difference of pi, that is current is leading. Now we'll go to the impedance. So the impedance is nothing but the opposition of circuit flow of alternating current. It's like a resistance. Impedance is very similar to resistance. Here we have resistance as well as capacitive reactance combinedly known as impedance. That is nothing but opposing the flow of alternating current. It is denoted by Z. So the impedance triangle is available. This is the resistance R, that is in phase with the current. This is capacitive reactance Xc. That is the voltage is lagging the current, so that is gone downwards. The voltage is lagging. That is current is leading but voltage is lagging. The sum of these two R and Xc is nothing but the impedance. So this is the phase angle between the R and Z pi. So from that based on that we can write the impedance Z equal to R minus jXc. This minus represent it is downwards lagging. Voltage is lagging. So that can be written as Z modulus of Z into pi, angle pi. It's a polar form. How will you find modulus of Z? Square root of r square plus x square. Then how will you find the pi, the angle, phase angle? So from this triangle we can find sin pi. Sin pi equal to opposite side by hypotenuse. Xc divided by r. Xc divided by Z. Opposite side by hypotenuse. Xc divided by Z. From that cross multiply this. So Xc equal to Z into sin pi. Similarly find the value of cos pi. Adjacent side by hypotenuse. Adjacent side r by Z. So cross multiply this so that r equal to Z cos pi. Similarly find the tan pi. Opposite side by adjacent side. Opposite side by adjacent side. Xc divided by r. So that pi equal to tan inverse Xc divided by r. So pi equal to minus tan inverse Xc by r because it is lagging. So from this the pi can be calculated from this value. So impedance given in rectangular form as well as polar form. This is a polar form. Now we'll go to the power triangle. Based on this we can analyze the power triangle. So the power triangle we have three different power available. It's a real power are called active power, actively utilized in the circuit. Its term is P, the unit is kilowatt. Another one reactive power, not consumed but it will react with the circuit. Some power required to initiate the circuit is called a reactive power. This term is Q, kVAr. Why it is downward? Because the voltage is lagging. Current is leading but the voltage is lagging, so that it is drawn downwards. The sum of these two, real power and reactive power, is the apparent power, total power, kVA. So S equal to square root of P square plus Q square. That is kVA equal to square root of kilowatt square plus kVAr square. Right? So the real power, reactive power and apparent power. Now we will see the definition. Apparent power is nothing but it is defined as the RMS value of voltage and current. S equal to V into I. The unit is kVA. Apparent power means RMS value of voltage and current. Now we'll go to the real power. It is defined as the product of applied voltage and active component of the circuit. Real power or active power means active component. What is active component? The power which is actually consumed or utilized in the circuit. For energy conversion, actually it is consumed. The power is actually consumed. Some of the power is not consumed. It is dropped in the circuit. That is called a reactive power. The power fully utilized for conversion is called a active power. So that is represented P equal to VI cos pi. The unit is kilowatt. Right? The power which is actually consumed or utilized is called a active power. Then what about the reactive power? It is the product of applied voltage and reactive component of the current. Reactive component. What is reactive component? The power which flows back or forth. That means it moves in both the direction in the circuit or react upon itself. The power is not converted. It is reacted. It is dropped in the circuit itself in order to initiate and other purpose. That is called a reactive power. So Q equal to VI sin pi. The unit is kVAr. Right? Now we discuss about the apparent power, real power and reactive power. Based on that we will go to the power factor. Power factor is a ratio of real power to apparent power. Real power or true power. What is true power? Real power VI cos pi. Apparent power VI. VI got cancelled. It is cos pi. So power factor is nothing but cos of angle between pi. The pi is nothing but the angle between current and voltage. So the power factor defines the cos of angle between current and voltage. So current and voltage, the angle between current and voltage is 0 means we'll get the better power factor 1. Cos 0, the angle is 0, cos 0 means 1. And another formula also available, the cos pi from the triangle, impedance triangle, we can find R divided by Z. Cos pi also calculated from the impedance triangle, that is R divided by Z. So pi is the angle between supply voltage and current. So in this video we discuss about the RC series circuit. Resistor and capacitor is connected in series. What is the behavior of the circuit? Thank you.